Imagine waking up tomorrow morning to find that every single human language has completely vanished from your memory. To survive, humanity agrees to a new universal communication system based entirely on numerical vectors. In this system, each position in a string of numbers answers a specific question about the concept you want to communicate. We have successfully replaced arbitrary historical sounds with pure structural properties. This array acts as our dictionary. The first dimension indicates noun or verb. The second represents gender. The third distinguishes singular and plural. It grows from there. Hundreds of new dimensions categorize concepts into domains like science, history, or biology. Communication starts out agonizingly slow. You stand before massive walls etched with columns of data, analyzing every number one by one to find the meaning. But with time, you stop seeing individual numbers. Your brain begins to recognize the overarching shape of the vector as a single familiar pattern. You no longer need to memorize words. Even if you see a vector you've never encountered before, you can deduce exactly what it means just by looking at its coordinates. Then the rules change again. Writing is banned. You must now communicate these vectors through sound. Assigning a unique random noise to each of the 40,000 vectors is impossible. The human brain cannot survive that level of brute force memorization. The only logical solution is to stop trying to name the whole word. Instead, we assign short, distinct sounds to the individual dimensions inside the vector. We map the verb dimension to the sound R and the plural dimension to S. Hearing those sounds means hearing the vector's coordinates. We do this for any recurring property. Every vector with a movement dimension gets the root move. By stacking these mapped sounds together, move, R, and sus, you have just built a word from its mathematical parts. This is how we arrive at roots, lexemes, and suffixes. Human speech is a complex system where physical fragments of sound map directly to these recurring logical structures. Language is a data compression algorithm, existing to bypass the physical bottleneck of the human body. Speaking takes a massive, multidimensional web of thought and squeezes it through a narrow funnel, emerging as a single line of sound. Listening is the reverse. The brain unpacks that linear string of noises, unfolding it back into a rich structure of relationships. Meaning lives entirely within the transformation rule that connects the noise to the structure. Our vector world was built in a lab. Real languages evolved through millions of years of messy biological and cultural use. But the top-down vector system we just imagined is the exact architecture powering artificial intelligence today. Large language models use word embeddings to map every human concept into a high-dimensional mathematical space. Modern AI lives in the vector world. An AI that only learns which word fragments statistically appear next to each other is only mimicking the surface of our language. It possesses the compressed file, but lacks the internal rule set required to actually open and decompress it. True intelligence requires discovering invariants, the underlying relationships that stay the same, whether they are expressed in Spanish, English, or mathematical vectors. A true dictionary must connect grammatical structures directly to raw physical experiences. Comprehension is the mastery of the law that converts the perceived universe into language, and language back into a representation of the universe.